Welcome to The Explainer. Today, we're embarking on a genuinely fascinating journey to uncover the invisible magic happening right inside your phones, your laptops, and, well, across the entire globe. We use the internet constantly, right? For studying, gaming, streaming, messaging. But how often do we actually stop to think about how it works? Let's crack open the digital hood.
I want you to think about the physical reality of what occurs behind that glass screen the exact moment you hit send or search. You type your screen and literally within milliseconds, a video starts playing or a message reaches a friend on the other side of the planet. It feels like magic, absolutely, but it's not. It is an intricate, highly engineered dance of hardware and software. And the choreography for that whole dance, it's all written down in a master rulebook. And that rulebook is called the TCP IP model. Now, you might have heard of other conceptual models in your classes, like the OSI model, which is great for dry theory. But the TCP IP model? This is the internet's practical blueprint. This is the architecture actually used for real-world communication in cyberspace. It's exactly how your device talks to a server thousands of miles away and ensures they understand each other perfectly. Okay, let's dive right into this. The TCP/IP model breaks this massive task down into 4 manageable layers: the application layer, the transport layer, the internet layer, and the link layer. To really grasp how this all works, we're going to take a top-down journey through these 4 layers, and to make it really stick, I want you to imagine we aren't just sending digital data, we're actually shipping a physical package across the world.
Layer 1, application, the gift. This application layer is where you, the user, are actually interacting. Whether it's the web browser you're using with HTTP or HTTPS, DNS acting as a translator for web addresses, or SMTP for your email. These protocols provide network services directly to your applications. They're essentially creating the core data, boxing up our digital gift.
Moving down to Layer 2, transport, the bubble wrap and label. At this transport layer, your data gets prepped for end-to-end delivery between processes, using specific ports so the receiving computer knows exactly which app the data is for. Now, this layer has 2 main delivery services, TCP and UDP. Think of TCP, the transmission control protocol, kind of like registered mail. It requires a signature. It guarantees reliable order delivery. If a piece goes missing, TCP literally demands it be resent. It's perfect for loading web pages or emails where accuracy is absolute, non-negotiable. UDP, the user datagram protocol, on the other hand, that's like tossing a handful of postcards into the wind. It's incredibly fast and connectionless, but it doesn't check to see if every single card arrived. It's perfect for things where a tiny drop in quality is okay, but lag is the ultimate enemy, like your live online gaming or a real-time video call.
Next up, Layer 3, internet, the mailing address. This internet layer provides logical addressing, like IPv4 or IPv6, to figure out global routing. But here's the crucial realization. The internet does not use dedicated lines. Think about it. When you call someone on an old-school landline, a dedicated physical circuit is held open just for your voice. The internet doesn't work like that at all. It is way too big and way too busy to reserve a private road just for your Netflix stream. Instead, the internet layer uses something absolutely brilliant called packet switching. Rather than sending your whole packet at once, it chops your data up into tiny independent pieces called packets. Each packet gets its own address label and is just sent out into the network. And here's the crazy part. Pieces of the exact same message might travel completely different global routes. One packet might go through London, another through Tokyo, all just to avoid network traffic jams or broken cables. Once they all arrive at the destination, they are perfectly reassembled. It's a real game changer that makes the network incredibly efficient and resilient.
Finally, we hit Layer 4, link, or network access, the delivery truck. This link layer is where our logical data finally meets the physical reality of local hardware. Depending on where you are, your packet might be pushed over Ethernet copper cables in a campus computer lab, or it might be transmitted via Wi-Fi radio waves in your dorm room. As it travels globally, it might bounce across 4G or 5G mobile towers, or even race at the speed of light through fiber optic submarine cables resting at the very bottom of the ocean. Basically, the link layer handles whatever physical medium is right in front of it. Now let's talk about encapsulation, wrapping it up. To bring our entire journey together, let's see how encapsulation actually builds as data moves from your screen to the network. Think of it exactly like a Russian nesting doll. You start with the core application data. As it drops to the transport layer, a header is added, turning it into a segment. Then it drops to the internet layer, where an IP header is wrapped around it, turning it into a packet. Finally, it hits the link layer, where a final header and trailer are added, turning the whole shebang into a frame. This frame is then translated into raw bits, ones and zeros, to be blasted over a wire or through the air. Every single layer adds its own specific instructions to the outside of the doll.
But remember, this is a two-way street. When those raw bits finally reach the destination computer, the exact opposite happens. The link layer reads and strips off its frame header. The internet layer reads the IP address, confirms it's in the right place, and strips its header. The transport layer reads the port number, strips its header, and hands the perfectly unwrapped core data up to the receiving application. The nesting dolls are unpacked, one by one, until the gift is finally revealed.
And that brings us to our final thought for this explainer. Look at the device sitting right in your hand right now. Can you imagine this incredible, complex, four-layer dance of encapsulation, packet switching, routing, and unwrapping happening millions upon millions of times a second? Every single time you load a picture, send a text, or stream a song, this entire global infrastructure leaps into action just for you. It's not magic, it's the TCP/IP model, and now you know exactly how it works. Stay curious, keep exploring, and I'll see you in the next explainer.